In this lab today, we are going to be trying to find the mass of a black hole based on the known mass of a star and the calculated net forces that happen to the star based on the gravitation of the black hole. So the way we're going to do that is by applying the physics principles of the law of gravitation, momentum, and net force. So the law of gravitation states that the force of gravity from a object is the gravitational constant, 6.67 times 10 to the negative 11th, multiplied by the mass of the black hole, multiplied by the mass of the star, all over the magnitude of the radius squared. The momentum is the product of mass times velocity, and the force is the rate of change of momentum multiplied by p hat, and it also is the sum of parallel net force and perpendicular net force. So by knowing these objects and knowing that the mass of the star is equal to 2 times 10 to the 30th kilogram, we can calculate the mass of the black hole. So to do this, we are going to input it into a computational model. And to do this first, we are going to look at the path of the star as it gravitates around the black hole in the time iteration of 1 day. So we're going to have to set time step to the seconds in 1 day. And then we're going to have to insert the collection of equations, as we see on the right, to calculate the final mass of the black hole. With having a known initial velocity, we are going to find the initial and final momentum by multiplying the mass times the known velocity. Then we are going to calculate the change in velocity as well as the change in momentum. With the change in momentum known, we are going to find the rate of change of momentum by dividing the change in momentum divided by the change in time. Then we are going to set this equal to net force. Next, we are going to find the p hat, which is just the initial momentum divided by the magnitude of the initial momentum. Then we are going to find the magnitude of the rate of change of momentum by dividing the change in momentum divided by the change in time. Then after multiplying that by p hat, we can find the parallel component rate of change of momentum. We are going to set that equal to the parallel component of the net force. Next, we will find the perpendicular component of the rate of change of momentum by subtracting the parallel component from just the net rate of change. Then we are setting that equal to the net force perpendicular component. Having found that, we are going to solve for the mass of the black hole by taking the radius, which we know by subtracting the origin from the star, and then we are going to plug it into the equation that we explained in the previous slide. After that, we will have solved for our mass of our black hole. Then we are going to represent in our calculations the arrows by just multiplying the forces by the arrow scales. And that looks as follows. As you can see, the forces parallel and perpendicular of the gravitation change as the star travels in orbit around the black hole. Because of this, to find the correct mass of the black hole based on the changing net forces, we have to take the averages of each time step all together to find the correct mass of the black hole. To do this, we just add up all of the masses together and then divide them by the number, and we can find the average. Once that comes out, it comes out to a mass of 2.16 times 10 to the 34th, with a net force of 1.06 times 10 to the 29th, a force net parallel component of 4.66 times 10 to the 27th, and a F net perpendicular component, which is 1.06 times 10 to the 29th. So altogether, what does this mean when relating momentum and net force? We know that momentum is a vector quantity and net force is a scalar quantity. However, their connection is that net force is the magnitude of the rate of change of momentum. And this is the same is true for its perpendicular and parallel components for both rate of change of momentum and net force. What would happen if the mass of the black hole changed? How would we be able to find it, and would this be different than the mass that we previously found? If the mass was to change, it would be different because it would affect the net force, parallel, and perpendicular force on the star from the black hole. Since this would be affected, it would alter and edit our calculations so that the new black hole mass would be different than the one we previously found. And that is all we have time for today. Thank you.